When working with electrical circuits, I've found these battery holders to be the most effective holders. They're available from many of these science supply houses that supply elementary schools. You can take a D-size battery and just flip it in place like that. The nice thing about these is that they actually clip together. So now I've got two cells connected in parallel. And I can easily add a third as well. And they only clip together in one way. I cannot clip them together this way. The only way I can do that is by putting them upside down. And so they can only go together in this way here. And then you can also put them in series easily. They have a dome on either end, and you can actually clip them together and put then cells in series. So here I've got 3 cells in series, or I can then flip them together and put them in parallel. You can then use alligator clips, such as the wire here, and connect one end then to the positive, and take a second wire and connect that to the negative end of the cell. A circuit board that students can use for building parallel and series circuits can be readily made using some basic supplies. My board measures approximately 18 centimeters by 11 centimeters, but the actual dimensions are not critical. I've screwed on here 2 sockets, 2 lamp sockets, and connected short lengths of wire to each of the 2 terminals on each socket. Here we have 2 clips that are known as Fahnestock clips. And you can press the clips down and place a wire underneath. And you can then connect several wires under a clip. I've made a little switch using a paper clip. One end is screwed to the board together with a wire. The other end is bent up and sits on top of a screw with another wire attached to it. And when I press it down, it makes electrical contact, and that can then serve as a switch. And because you have to hold it down, as soon as you release it, the circuit will open up. We can then take our battery pack, 2 cells, either in series or in parallel, and we can connect then one end to the wire going to the switch, and the other end we can connect to the Fahnestock clip, for example, like that. Then I can take some light bulbs, and I'm using a number 41 2.5 volt light bulb, and these are available in packages of 10, and you can screw those light bulbs into the socket. So now I have 2 light bulbs, and if I connect the terminal, I'll connect just the first lamp into the circuit like that, and then if I close the switch, we then have the light illuminated, as you can see here. If I take my cells and I place them in series, we can disconnect them a minute, pull them apart, and clip them together. They only go in one direction, and I connect my red end to the one. Notice again that we can just clip the alligator clips to there, and now we've got 2 cells in series, and together with a lamp and our switch. And when I press the switch, we now have a much brighter light. And so we now can trace the circuit, so the electrons can flow through the light bulb to the batteries and to the switch. And when we close the switch, the light is then illuminated. We can place two lights in parallel by catching the wire underneath the clip there and attaching the other one here. Now I've got two lights in parallel. They're both connected to the same connections here, and then in series with the switch and the batteries. And if I press the switch, both of them go on. To put them in series, we can have to set it up a little bit different. So we have to go from here through the light bulb to here to this light bulb, and now the other end of the battery is connected to the wire on the second lamp. So now to sort of trace the circuit, electrons must flow through here, and then back to the battery, and here they come from the batteries. So if we press the switch, we now get it fairly dim. If I unscrew one of the lamps, both lights go off. It doesn't matter which one I unscrew, they both go off. And that's because we now have an open circuit when I open the lamp. My switch is still down, but the light bulb being loose, or I can take it right out, means that electrons have nowhere to go. And then we can also do the lamp in series, the two lamps in series, with these cells in parallel. So connect the cells in parallel. And now we close the switch, and the lights are extremely dim. You can just barely see them glow. Why is that? Well, when the batteries are in parallel, the voltage is the same. And we can measure that using our voltmeter. So here's my voltmeter. I've set it to 2 volts. I connect the black terminal to the negative end of the battery and the other terminal to the positive end. And you can see that we have a voltage of about 1.58 volts being generated here. If I put the cells in series, and connect the lamps up again. Both our lights are on, and now we measure the voltage. We'll have to go to a higher scale. I'll set it to 20 volts. And now we connect our leads from the meter, and we see that we have a voltage of about 3.1 volts, twice the voltage. So by putting the cells in series, we actually double the voltage. By putting them in parallel, the voltage stays the same, but it's capable of delivering a higher current. Here again, I have 2 cells in series connected to a single light bulb, and you can see the light is quite bright. Now these are 2.5 volt lamps. If I leave it on for an extended period of time, the lifetime of these lamps will be reduced because they're really designed for 2.5 volts, and 2 of these in series will give me about 3 volts, or in a little bit. If I put 3 of them in series, if I were to add another one, that would generate about 4.5 volts, and that will tend to burn the light bulb out very quickly. Not recommended. So don't put 3 of them in series with a single light bulb. If you don't have a set of alligator clips for every group of students, you can also just use wires to connect the cells to the board. If you look at these, you can actually squeeze the wire in behind the connector on that end. You can take a second wire and do that on the other end, and then connect the wire to the circuit board. So now I've got my cells, switch, the lamp, and back to the cells again. So that's my circuit. When I close the switch, the light goes on. So that's another way of hooking the system up, which doesn't require the use of alligator clips. It's just that alligator clips are very convenient.